All right, so this next example, a box contains 3 markers and 2 crayons. An art utensil is drawn at random from the box and not replaced. A second art utensil is drawn. Okay, so I have 3 markers, which I'm going to label M, and 2 crayons I'm going to call C. So part A says we're not replacing it, and then draw a tree diagram. Now it does, I'm going to actually find a probability, but first I need to draw my tree diagram. So the tree diagram, I have a box. Here's my pretend box. Marker, 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 crayon, crayon. All right, that's what I got happening in my box. I'm going to randomly draw one thing out, record it, not put it back, and then draw another one. So an example of what's happening, I stick my hand in, I draw out a marker, I'm not going to replace it, then I draw out another one, and so one possible outcome would be I drew a marker first and then a crayon. All right, so that's what's happening. Oops. Okay, so let's look at my tree diagram. Upon first draw, I have that I can either draw a marker or I can draw a crayon. Those are my only 2 options. On the second draw, I can draw a marker or a crayon because I'm drawing from the same box. Now let's go in and fill our probabilities in so we can use that shortcut of what we saw in the previous section or the previous videos. So on the first draw, this is all happening on the first draw. On the first draw, the probability of a marker is there's 3 out of a total of 5. So the probability of a marker, 3 out of 5. Still on the first draw, so I'm looking right here on the first draw. First draw, second draw. On the first draw, the probability of a crayon is 2 out of a total of 5. Now, I've drawn something and I am not replacing it. So this says on the first draw, I drew a marker and didn't replace it. Okay, so I drew out a marker. We'll just stick it up there somewhere. I drew out the marker and I did not replace it. Now I have to draw again. Well, what's my probability? Well, now I only have 4 things left because I didn't replace that marker, and 2 of them are markers. So 2 out of 4 on the second draw. Okay, this says I drew a marker. What's the probability of a crayon? Well, there are 2 out of a total of 4. Now, I'm going to reduce later. Okay, so now, second scenario, I draw a crayon. So that marker's back in. Oops. Marker is back in. Gosh. And I am drawing out. Oh, I just want to grab the crayon. Well, here, let's just draw a new box. Marker, 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 crayon, crayon. All right, so that's my, ignore all that. I don't know what it's doing over there. So now, let's rewrite this part. Now, I drew out a crayon and I didn't replace it. Okay, so let's take the crayon out of my box. I'm not replacing it. So what's left inside? There's still 4, but what's the probability of a marker? Well, there are 3 markers out of a total of 4. Because I took that crayon out and I did not replace it. The probability of a crayon, okay, I took one out, so I only have 1 left behind out of a total of 4. And now, if I needed to find all the probabilities of these, I could multiply. For practice, I'm going to do it because it's worth seeing again. So the outcomes and the probability. Outcome would be marker, marker, and the probability would be multiply on that angle, or sorry, on that tree. So we've got 3/5 times 2/4. All right, multiply across the top. And just like your fraction rules, you can simplify before you multiply. Across the top, I've got 6. Across the bottom, I've got 20. Divide top and bottom by 2 and get 3/10. Now, make sure that you do at least simplify at the end. I don't care if you simplify along the way, but at least simplify before your final answer. So if you had simplified this here, it would just make these numbers smaller. But we'd still all get 3 out of 10. All right, the next one, marker, crayon. That's going to be 3/5 times 2/4. Or again, you could have that as 1/2. All right, multiply across the top, 6, across the bottom, 20, and 3/10. All right, crayon, marker. So multiply those, 2/5 times 3/4. Now this is a good one, just as a reminder. If you can simplify on the diagonals, you can certainly do that. Divide out your common factor of 2. You can do that, or you can divide it out at the end. All right, so multiply across the top. I've got 6/20, which again gives me that 3/10. Or, had you simplified, divide across the top, you would get it when you multiplied. All right, and then the last one, crayon, crayon. I've got 2/5 times. Again, that's one where you could divide. All right, 2/1 is 2, 2 times 1 is 2. 5 times 4 gives me 20. Divide top and bottom by 2 and get 1/10. When you do these, if you've done them correctly, all of these numbers should add up to 1. So 3 plus 3/10 plus 3/10 plus 3/10 plus 1/10 does give me 3, 6, 9, 10/10. So that's a good check. Not required, just bonus information. So now the actual question, that was all my tree diagram, and then I kind of built in a review there. Find the probability that two utensils are the same. So find the probability that two utensils are the same. All right, well, that would be marker, marker, or crayon, crayon. And what I can do for my or is I'm going to add those two probabilities. So the probability of marker, marker is 3 over 10 plus the probability of crayon, crayon, 1 out of 10. Add up the numerators. 3 plus 1 gives me 4. Keep the denominator. And then make sure you always simplify. All right, so that is part A. Now, part B says, all right, suppose that your utensil is actually replaced. Draw a tree diagram and find the probability that the two utensils are the same. So pretty similar, except instead of not replacing, we are going to actually replace the utensil. So the probabilities are not going to change. All right, so I've still got marker, crayon, marker, crayon, marker, crayon. All right, the tree diagram itself has not changed. The probabilities will be different from not replaced to replaced. So now we are replacing. All right, here's my box. Marker, 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 crayon, crayon. Now what this says is I'm going to draw out the marker and then I'm going to put it back in. So before I do any drawing, on the first draw, the probability of a marker is 3 out of 5. The probability of a crayon is 2 out of 5. Now what this says, I am drawing out a marker and then I'm going to put it right back. And then I'm going to draw again. So now the probability has not changed because I drew the marker out and then I put it back and then I make my second draw. So now the probability of a marker is still 3 out of 5. Probability of a crayon is still 2 out of 5. Now this scenario says, okay, you drew a crayon on the first draw, drew the crayon, but then you put it back. And so the probabilities are going to stay exactly the same. 3 out of 5, 2 out of 5. And now, I'm not going to just for sake of time in the video, but if I needed to, I could find the outcomes and the probabilities just like we just did. Marker, 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 crayon, crayon, marker. I could find those probabilities by multiplying. That would be 3 out of 5 times 3 out of 5. And then this one I would multiply to find that. And I could find all of those like we just did. For sake of time, though, I'm only going to look at the ones it asked me about. So going back to the question, I have found the tree. I've drawn the tree diagram. Now find the probability that the two utensils are the same. So the probability of marker, marker, or crayon, crayon. So really the only two probabilities I need to find are those two. I could list them all out, but just for sake of time, we're not going to. All right, so the probability of this one is going to be 3 out of 5 times 3 out of 5, or 9 out of 25. Probability of this one would be 2 out of 5 times 2 out of 5, which is going to give me 4 out of 25. And then, because I'm looking for that or that, I'm going to add those two together and multiply. So this says I'm looking for marker and marker, marker and marker, so I multiplied. I'm looking for marker, marker, or crayon, crayon, so I'm going to add. So I've got 9 over 25 for the marker, marker, 4 over 25 for crayon, crayon. They already have a common denominator. 9 plus 4 is going to give me 13, and that would be my probability. And there's several types of questions we could ask about this. We're going to see it on the review, but this at least gives you several examples to help get through the homework.